So we're looking at the Edexcel calculator paper. Okay, you should have timed yourself, yeah, 1 hour and 30. What I recommend is have 1 hour and 30, do it all in blue. Once you're 1 hour and 30, stop the clock. If you haven't actually finished, if you're taking too long, you could then continue in a different colour pen. But when you mark it, you realise, well, this is what you did in the time. This is what you were capable if you hadn't taken so long. Okay, so that's significant. Right, I'm just seeing here it says protractor. Oh, anyway, it says that we need one of them. Ryan will drive his car in Spain. The speedometer on the car shows the speed in miles per hour only. He'll be driving on roads with a speed limit of 100 kilometers per hour. Ryan uses this rule to find out his speed in miles per hour. So the kilometers divided by 8 times by 5 is the miles. Ryan thinks that 70 miles is the same as 100 kilometers. Now these people at Edexcel, they like this type of question. Somebody thinks this, are they right, are they wrong, work it out, but then remember to say yes or no. When I taught this last year, students would do the work or most of the work, but then they'd forget to say the conclusion, yes or no. Okay, so we've got 100 here. So we've got 100 divided by 8. So obviously this is a calculator paper, and I think do it, make it quick, be logical, think if you've done it correctly, and move on. So typing that into my calculator says 12.5. So then it says times by 5. Oh, 12.5. Ah, that's a 5. Times by 5 equals 62.5 miles per hour. Okay. Is it the same? Nope. Okay. Now sometimes with Edexcel, it's kind of similar. I think one of the questions I've seen, or maybe a different paper, it says, was it a third? And the answer was 32%. And you're thinking, no, not quite the same. We want perfection. Okay, looking at the marking scheme. So we get 1 mark for writing that. And what's going on with the marking scheme is it's trying to think about the different ways in which you might have tackled it. And they're saying what you could have done was done the reverse of this and worked out if this was the opposite of that. Okay, I suppose you might have done. So just ignore the second line. Just if you see what you got, and then it says we've then times by 5, we've got no, and we've got this here. And the bit in brackets saying I didn't have to write miles per hour, but it's okay if I did. I think I read somewhere that if you do write something, it has got to be true. Okay, so I suppose if I wrote km per hour there instead, then that would have been wrong, because that would have been showing me that I was a bit confused what was going on. Okay. Nicola wants to buy 30 litres of white paint. She sees a special offer, white paint, 10 litre tin, usually £38, 15% discount. She uses a special offer. Okay. She has a budget of £100. Does she have enough to buy 30 litres of white paint? So I'm thinking that means 3 tins. Yeah, it's called a tin. Just checking, because they come in plastic now. Plastic tin. Okay. 38 times by 15%. So I always write my 15% like this, even though when I type it into my calculator, I actually type in 38 times 0.15, whichever way. I'm just telling you my way. Okay, and we've got 538 times 1.5 equals, my fraction, my calculator is obviously displaying that as a fraction, so I press my S to D button to change it into a decimal, get 5.7. This is currency, so I should remember to put my 0 on it. Okay, so 38 take away 5.70. And again, even though I'm using my calculator, I would prefer to write it as a takeaway sum, because I'm seeing straight away so that's what my calculator should be saying. Okay, that's 15%. Then I take the 15% off. Another way in which you can do it, you don't have to, is if I think, well, 15% off, well, 100 take away 15 is 85. So I could say 85% of the original price. Again, that's what I write. What I type in is 38 times 0.85. Press my fraction button. Is 32.30. Okay, actually, yeah. So that's a different way to do 15%. Either way, we've got a tin costing 32.30. She wants 3 tins. £96.90. I'm happy with that. But remember to answer the question, does she have enough? So we've got to say yes. If you forgot to write that yes, you lose. You don't earn that 1 mark. Okay, just checking here. We've done 15% is there. We've got a different way to do it. So there, it's actually showing you this 85%. Not sure what the last one is doing. Maybe they've worked out 3 tins of paint is 38 times 3. So they're saying 3 tins of paint would normally cost 114, but then you get a £17 discount. Okay. We got a 32.3, and then I'm not sure what that's doing. I don't care. Right, what I'm seeing here is I've got the word yes, and I've got this amount here. So I'm happy with that. So we get 4 marks. So that's the way with the marking scheme. With these, they're trying to show you all the different ways in which somebody could have worked it out, so give you the marks for it. But what I generally do is look at the bottom and see, I've got the 96.90, so I get all the marks. Okay, so don't worry so much about this marking scheme. It's good if you could mark your own work. It's good if you could understand enough to have a guess of how much you think you got. If I was marking it, I'd mark it very precisely. If you're marking it, whether you get 24 or 27, it gives me an idea of what mark you're working at. Okay. Yeah, so don't worry about it so much. fact that you can mark it yourself is brilliant, that you're understanding where you've gone wrong, what you could have done different. Okay, but yeah, don't worry about that. There's loads of different things you could do. Luke wants to cover this wall with blue paint. He will buy blue paint in 2.5 litre tins. Each litre of blue paint will cover 8 metres square of wall. How many tins will he need? Okay, first off, I'm looking at the wall, I'm looking at the 7 and the 3.6 and thinking, how much is the area of the whole wall? So 7 times 3.6 equals 25.2 metres squared. Obviously, we've got a door that we're not painting. What's the area of the door? If you see here, 3.6 minus 1.6, so it's 2 metres tall. That seems reasonable to me. Yes, when I look at a door, I think it's 2 metres tall. And here, 7 and 6.1, so it's saying it's 0.9 metres wide. Again, that seems reasonable to me. So we got 1.8 metres squared. So the area to paint, if I put wall, we got this one, take away that one, which is 23.4 metres squared. Might as well change my colour pen because I like different colours. 1 litre is 8 metres squared. We got 2.5 litre tin. So how much area is that? If I'm thinking, what do I times 1 by to make it a 2.5? So times by, I want to change my so 2.5 times this side by 1 by 2.5 times this side by 2.5. 8 times by 2.5 is 20 metres squared. Okay, so that means 1 tin isn't enough. Okay, how many tins of blue paint does Luke buy? Well, he'd need 2 tins, 2 tins of paint. So even though we did the calculation with taking the door off, yeah, we still haven't got enough paint with 1 tin. Okay, looking at the marking scheme, so it's got the door missing, finds relevant area. So we've got, I don't know where that number's coming. We got that. No, where we go? Okay. What have we got here? Right, the last question, I started looking at the marking scheme and paused it, and then I couldn't go back to it, and don't understand a lot of what's on that marking scheme. I saw some numbers that were matching. I've got 2, so I'm happy. Right, question 4. Chris is designing a badge. The badge needs to be a trapezium. Uh-oh. What does a trapezium mean? It has a base of length 6 and has only 1 line of symmetry. Okay, so trapezium. I know what trapezium is. but it's not something that I used to teach, so I'm thinking you don't know what a trapezium is. One line of symmetry. I'm thinking, if you haven't got a clue, draw a base of 6. Oh, went too wrong. So if we really haven't got a clue, thinking, well, it's got a base of 6, so it's a line 6 squares long, one square, one square, one line of symmetry. If that's as much as you could do, that's fine. Looking at the thing, you get 1 mark for doing that. Okay. A trapezium, we've got squares. It's going to be, it could be a parallelogram. You could draw a parallelogram. Parallelogram doesn't have lines of symmetry, so it's not one of those. A trapezium is that kind of shape. Okay. So 2 parallel lines and triangle kind of things. It has, the version needs to be shape of trapezium, base of 6, 1 line of symmetry. So line of symmetry is going to go down here. I'm just thinking it's that. So you can see there, we'll wiggle it instead of dotting it. That's trapezium, 1 line of symmetry. Okay, I could have drawn it different. I've got room here. There's another one. I could have drawn it wider at the top and shorter. There's another trapezium. Okay. Marking scheme says draws a trapezium, a line 6 centimeters, closed shape with 1 line of symmetry. Okay, so it's saying you can't have it as a it's just saying the same thing again. Oh, I suppose it's saying you've got 1 mark for the 6, 1 mark for line of symmetry. So and then and the fact that it is a trapezium. Okay, so trapezium is a word we need to learn. We need to see what other words like this that we need to learn, and I would make a note of the word trapezium on your front sheet. Okay, Jim works in a shop. He has this information about 72 items sold last week. I'm going to put a 72 there. There's a total. Jim starts to display the information as a pie chart. Complete the pie chart. Okay. Thing about pie chart is how many degrees is in pie chart. So if you think, if this is 90 degrees, 2 lots of 90 degrees is 180 degrees, which is a straight line. And then if I want to add that straight line and that straight line together, we've got 360 degrees. Okay, so from here, from the beginning, all the way around is 360 degrees. It says you needed a protractor. So protractor normally looks like that kind of shape, doesn't it, with the 180 degrees. If you haven't got a protractor, I'd still expect you to do as much working out as you can. Buy one from Poundland or wherever, but obviously it's not easy to get to the shops at the moment. 15 tablets sold is 75 degrees. I think we need a circle there. So if you think the 42 is like 42 out of the 72, okay? So ask your calculator, 42 divided by 72, it will give you as a decimal 61. It's a little dot above the 1, so I'll press the S button again to get rid of the dot. So it's 0.61111. That's as a fraction of a decimal. So if I times, I should write this down. 44 divided by the total 72 equals 0.6111. So that's as the decimal was a fraction. If I then times this number by 360 degrees, I get an answer for degrees. 220, that's a nice number, isn't it? 220 degrees. 220 degrees bigger so you can see it. Okay, similar with the 13. Change my color pen. The 13 divided by the 72. 13 divided by 72. Fraction as a decimal, it's 0.1805. There's a little dot above the 5, so press the button again, and it's lots of 5s this time. So I'll times that by the 360 degrees. That's how my answer becomes degrees. So 65, that's nice. I could just do a little bit of checking. 15 divided by the 72 times by the 360 is the 75 that it said, and let's just check. If we add these three numbers up, we should get back to the 360. So 75 plus 220 plus 65 equals 360, so that's good, we haven't done anything wrong. So the tablet was already drawn. That was 75 degrees. Because my protractor is 180, it'd be a bit difficult to do the 220, so I'll do the 65, and that was green. Obviously, I can't use a protractor on this computer screen, so I'll just guess. Remember to label black top, and then I'm going to put 220 degrees here, and I'll put phone. Okay. I suppose it being a pie chart, you might not write those degrees on, but because it's a maths paper, it's easy to. Let me just see. So if we hadn't got a protractor, like I didn't, I could get 2 out of the 3 marks for this question. But I don't know what the first two's on about, but I see the 44 and the 72, meaning the 220 degrees. I've got 13 divided by 2, and it says these two labelled accurately. Haha! So it does want these to be labelled accurately. That's interesting. And then it says there that plus or minus 2 degrees, so that's saying the tolerance. So if this was 57 degrees, it might be just about okay, but if it was 58 degrees, you'd lose that accuracy mark. Fully correct and labelled pie chart, so they are wanting it labelled. I say it's implying there that you need your 65 and the 220 rather than the laptop and the phone. Okay. Now, this question, Ben is an activity leader, so it's like Scouts leader or Duke of Edinburgh, or, you know, it's a leader. It could be an activity centre, team building day or something like that. He's planning a team building event for a group of people, so yeah, company going out. Ben has this part of a map. That's a very boring map. Okay, it's got a key. 1 centimetre is 100 metres on the ground. Okay. The group will start at point A and walk directly to point B. You will need to write the instructions given to the group. The instructions need to include the bearing and the distance to be walked. Okay, so I'm not sure if you know the term bearing. I'm just thinking if I was in the classroom now, I'd be showing you I've got a compass that points north and it's got degrees on it, but I can't show you that. So let's do the easiest thing first. So what's the distance? Drawn accurately. So you measure this distance from here to here. It's 6.3 centimetres. Okay, so here we've got 1 cm equals 1,000 metres. Obviously straight away I'm thinking, why didn't they just say 1 kilometre? That would have been easier for us, but obviously that's our job, not the paper's job. So 6 cm equals 6,300 metres. So that's 6.3 kilometres. That's a long walk. I'm thinking, yeah, it's like 2 miles, or it's more than 2 miles walking at a certain. Okay. Distance walked, done that one. So the bearing. So if you've got a compass that faces north, then you can work out which angle to walk in. So we need the protractor to measure this angle, and it's 110 degrees. So all you need to write here is all I wrote on mine was walk 6.3 kilometres at a bearing of 110 degrees. Okay. Oh, right, okay. Just looking at the marking scheme. So 110. Now here it's saying it's 6.5 centimetres, whereas I measured it as 6.3. It says I've got a tolerance within plus or minus 2 millimetres, so my 6.3 is okay. If I'd gone to 6.2, I wasn't accurate enough. Okay, and then we can convert. So this accuracy mark here, but even if I had it as 6, I could still get this mark. If I thought it was 6 centimetres and 6 kilometres, I could still get that mark. That's saying this one or that one. Okay, right. Right, I need to measure that now, but my ruler's downstairs and I'm going to go carry on. Ben records the time it took each person to complete the event. He has completed a table with the information. The mean time is 39 minutes. The range is 26. The longest time was 53 minutes. So what's the shortest time? So if you think range equals max take away min, what do we know? We know the range is 26. We know the max is 53, but we don't know the minimum. Okay, so I'm thinking there. So we don't know the minimum. I'm thinking there we could swap these two numbers around. that if I did 53, take away the 26, I get 27. Okay, let's just recheck that. So 53, the maximum, take away the minimum, the 26, would give me a range of 26. So that's right there. Okay. Yeah. Okay.